Hello everybody and welcome to my next video. So in this video I'm just gonna be helping out some people in my class with an assignment that's due tonight actually, so they might have to hand it in a bit late, but sorry for this. But for those of the people in my class, you guys better owe me a JBC tomorrow because I will feel afford JBC, so buy me a JBC. Thank you very much. Anyways, we have our standard functions right here that we're supposed to be using for our program, and these are our include statements. So these we have to be using them in this program, and I've already set up our variables, and we're supposed to set all these to 0 by default, and I set up our srand and our while loop. So we're supposed to be going, the years is going to be going till 3.8 billion years, so this is 3.8 billion written out right here. This should be standard stuff. So what's supposed to be going within our function, and for those of you who aren't in this class whatever but want to know what we're doing, you can visit this link right here. Click IPC 144 assignment number 3, and you can read about what the assignment is about. So in our gen atom, we're supposed to generate a random number between 1 and 4, so we can do this by doing this statement right here. In our process atom function, if the number is 1, then we have a hydrogen atom. If it's 2, it's an oxygen atom. The number is 3, then it is a nitrogen atom. If the number is 4, it's a carbon atom. Okay, so we're gonna pass in our number, we're gonna modify our charge and the amount that we actually have. So if the number is 1, then we're gonna increase our hydrogen value by 1 and increase the charge by 1. That's what it says to do on the website. Now if we have an oxygen, we're gonna increase our oxygen by 1, right? And if the charge is greater than or equal to 0, so if it's a positive charge, then we subtract 2 from it. That's what it says to do on the website. If our number is 3, which means it's nitrogen, then we add 1 to nitrogen, right? And if we have a positive charge, then we subtract 3 from it. But if we have a negative charge, then we subtract 1 from it. And lastly, we have our carbon. Now it says that if every single third time that we have a carbon, we have to do something different than a regular time we have a carbon. So this is what happens regularly, right? So we use the modulus operator to against 3 to see if it's a multiple of 3. So if it is not a multiple of 3, then if it's positive, we subtract 4, and if it's negative, we subtract 2. If it is a multiple of 3, then if the charge is positive, then we subtract 2 from it, and if it's not, then we don't do anything to it. Now later on in our program, it says, let's see, it says that if the charge value ever falls below -4, then you are to compensate by immediately adding 3 to the charge by adding 3 hydrogen atoms. Okay, so right here we say that if it's less than -4, we add 3 to the charge, we add 3 hydrogen atoms. Now notice that our process atom is the return value is a float value. It doesn't really explain it properly on the website, but it wants us to return the weight, right? So we have a get weight function, so what we're gonna do is just return the get weight, the weight from the get weight function. Okay, that's what we're gonna do. So now we're gonna start the get weight function. So these are the weights of the molecules that or the atoms or whatever that is specified on the website. So I stored all those in an array to make it easier, and you don't have to put in an array. You can use a series of if statements, whatever you want to do, but I did it this way to make it easier. And you can name it whatever you want. You can name it weights, whatever you want to do. And I'm gonna make another array, and I'm gonna name it temporary2 creative, right? And right in here I'm gonna put num_c, num_h, num_o, num_n. Now these are the same as the parameters right here. So what we're gonna do is, this might confuse you right here, and I hope it doesn't, but it very well might. but I will try and explain it. So we're gonna have a for loop, a regular for loop and a nested for loop. Okay, so I'm gonna say I is less than 4, I plus plus, for j equals 0, j is less than temporary 2, I j plus plus, and we're gonna have a float variable called weight set equal to 0, 0.0, and we're gonna say weight plus equals temp array I. So this is probably gonna confuse you guys, and I'm going to make it less confusing, but lastly, let's just return the weight right here. Okay, so what is going on right now? Okay, so look at this right here. So this is storing our weights, right? And these are the number of carbons we have, number of hydrogens we have, number of oxygens we have, and number of nitrogens we have. Okay, so okay, so for starters, what happens here is that I is going to be set equal to 0, and then it's going to go to this for loop, right? So j is equal to 0. Okay, now let's say we have 3 carbon atoms. Okay, what's going to happen is going to say we're going to loop. So j is equal to 0, j is less than temp array 2I. So what is I right now? I is equal to 0. Okay, so the value of num_c is equal to 3. So we're going to loop while j is less than 3. That's what's happening. Okay, and we're going to add 1 to j. So I hope that didn't confuse you, but we're going to be looping to how much that we specify, whatever values in here. So when we're going to keep on looping, and we're going to say weight plus equals temp array I. So we're going to take the value, which is since I is equal to 0, right, we're going to be taking this value and continuously adding to it depending on what numbers in here. So if we have 3 carbon atoms, right, then we're going to add 12.0107 times, right, because we have 3 carbon atoms. Now let's say we have 1 hydrogen atom. So what's going to happen is when it's done adding that stuff, then I is going to be increased by 1, right? Then it's going to go to this for loop. So j is equal to 0, okay? So it's going to loop j is less than temp array 1, right? Because I is equal to 1, so that's hydrogen. So it's going to loop until while j is less than 1, okay? So it's going to add this weight right here, and so on and so forth, and then we'll get the total weight of all the atoms, and then we will return that value. Okay, hope that didn't really confuse you guys. If it did, message me on Facebook or something. Okay, so molecule found. Okay, now the way the teacher, when I taught him today, he said he wanted you to you could use a bunch of if statements or blah 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 to compare the different compounds and so on and so forth. And these are the different amino acids right here, and you could check against the weight, or you can check against the formula. So if you have 3 carbons, 7 hydrogen, 1 nitrogen, and 1 oxygen. Okay, so it's up to you which one you want to do. You should check against both, but I'm only going to be checking against one in this one, and you guys can figure out the other way on your own, right? So what's going to happen right now is I'm going to I'm going to pause this video, and then you're going to see what I post. Okay, so right now you might want to name it differently than he said. He wanted us to use arrays, right? So now I have a pointer to 18, a pointer to whatever, an array, right? And if this confuses you, then it's up to you whichever method that you want to use, right? But this method is this method works for me. Okay, so basically I store all the amino acids in here, okay, and I store their weights in this array right there. So our alanine is equal to this weight as aspartic acid, whatever is this weight, etc., right? So what we're gonna do is simply we're going to do a for loop, and we're gonna loop till 18. I'm gonna say if weight is equal to acid weight I, then we print we're gonna print the actual name of the acid, right? And you're supposed to print out all the details of it, but I'm gonna leave that to you. And after that, we're gonna just put break. Now, one thing that we have to do, first of all, we have to put an I in here, and we have to have a return value. And we're gonna set that to 0 by default. So we're gonna say that if it is equal to one of the the weights, right, then we're gonna set our return value to 1, and then we're gonna return value. Okay. So if it returns 1, that means that it actually found an amino acid, and if it returns 0, that means it didn't find 1, right? So now let's get into our actual main. So right here, we're gonna say process atom, and we're gonna get, in our atom number, we're gonna call our gen atom function, the generator random 1. Then we're gonna put a reference to our charge, a reference to our hydrogen, reference to our oxygen, reference to nitrogen, and our reference, I know you can't see this, but a reference to carbon. Okay, and that's gonna be, and the return value is gonna be stored in weight, right? Cause remember, we return the weight of all of it. Okay, so it says that if our charge in the assignment says that if our charge is equal to 0, that means we should check for an amino acid, right? So we're gonna say if charge is equal to 0, then we're gonna say that if molecule found, and we put in the weight, our charge, carbon, hydrogen, oxygen, nitrogen. So if that's equal to 0, right? So like so. So if it's equal to 0, that means it says that we should reset all the values except for the year. So we're gonna copy this, paste that in there, and if you want to get creative or whatever, you can make a function called reset or something and call that and put all these values in the reset function and reset everything. But it's really up to you. And this should be 0.0. So it's gonna reset the value, and else we are going to break. And what break does is that it exits the loop that we're currently in. So right here, we're gonna increase our years by 1, and we're gonna say that if years exceeds our number, so 3.8 million years, then we'll print, and there's something that we're supposed to print. Oh, sorry, I was just looking up something. Oh, okay. So let's see what we're supposed to print. Yeah, right here. So life never formed on planet Earth. Okay, and that's how we're gonna print, and that should be it for this program. So we're gonna run this, and let's see if it runs correctly without any errors. So we never set anything to display unless it actually finds an amino acid. So what we're gonna do quickly is, we're gonna say int atom equals gen atom, and I'm gonna pass in the atom in there, call printf atom %d charge %d \n, and we're gonna pass in the atom and the charge. So let's run this. Let's see if we're doing everything right first. Let me check this and I'll Okay, so the problem was that we should set this to a float. We had this temporary as an integer, and therefore it was converting these numbers to an integer. So change that to a float, and for this, change it to %s. And let's run this program. Oh, you see it? It said alanine, then it closed down. Let me run this one more time. So you see it says alanine, right? So it got one of them. You're gonna see alanine a lot, and that one just said serine. So you're gonna see alanine and serine a lot, for whatever reason. But yeah, so that is basically it for this tutorial. And as for these parameters right here, you could use if and else statements or use arrays or whatever you can use in order to see if the carbon, hydrogen, oxygen, and nitrogen whatever match against the current compound. So if it matches, so if there's 3 carbon, 7 hydrogen, 1 nitrogen, and 1 oxygen, I mean 2 oxygen, right? So it's up to you to figure out how to do that, but I hope this at least helped you a bit. Thanks for watching. Hope you enjoyed it, and bye.